So hi guys, welcome to my channel. So today I'll be solving this GFG problem of the day, which is quick sort on linked list. So the difficulty of this problem is marked medium and the code is also looking very complex. But believe me, after I explain the code to you all, the code will be like cakewalk for you all. Like you all can write the code by your own after you'll get to know how to approach this problem. Okay, our problem is basically simply the algorithm of the quick sort. Like what approach I'll follow is, first I'll be explaining how the algorithm for the quicksort works for the one-dimensional array, and then we'll be slowly shift to like solving this problem and applying the algorithm on the linked list. Okay, so this is the array which is given to us and we have to apply the quicksort in this and we have to sort the array. Okay, so now what is the first step that we have to look is we have to find the start and end of the array. Okay, so let's say initially start is here and end is here. Okay, so first step is start and end. Okay, we have defined. Now next step, what we are doing is we have to find the, or we have to analyze the pivot element. Okay, so let's say for this case we take the first element as the pivot element. Okay, so let's fix it. Pivot pivot is equals to 5. Now moving it further, find the pivot element. Okay, now next what we have to do, move the pivot element to the correct position in the array. How we can do this? We can do this by, let's say this is 5, we will be calculating. Okay, so 5, some numbers would lie left to the 5 and some number would lie right to the 5. Okay, so what we'll be doing, we will be calculating the numbers which is smaller than the pivot element. Let's say 1 is smaller than the pivot element, 2 is smaller than the pivot element, and 4 is smaller than the pivot element. So what we'll be doing, we'll count it. Okay, so 3 numbers are there which is smaller than pivot element. Okay, so we will swap the index of pivot element with the index 3. Okay, I hope this is getting clear how we are applying the like quicksort. Okay, so move pivot to its correct position. Okay, so after that the array would look like 4 will be coming here, 1 will be coming here, 6 will be as it is, 5 will be swapped, 2 and then 7. Now after moving the pivot to its correct position, our next step is to like left of pivot. Okay, so left of pivot should be small and right of pivot should be greater. Okay, so let's say we have swapped the pivot element with this index 0, 1, 2 and 3. Okay, done. Now what we have to do, okay, so now we have to make sure that whatever elements towards the left of pivot element should be smaller and right of pivot element should be greater. Pivot element we have make the shifted the pivot element to its correct position. Okay, so now we have to put one iterator I and we have to put one iterator j. Okay, done. Now 4 is smaller than 5. Okay, yes, we have to make a while loop until and unless we got an element which is greater than 5, then we have to swap. Okay, so 1 is also smaller than 5, it's okay. 6 is greater than 5, it should not be present here. Okay, done. I have to swap this I. Now from whom we have to swap? Okay, so now let's see. 7 is greater than 5. Yes, 7 is greater than 5 and it is in the correct origin. Okay, now let's shift j to here. Okay, so now is 2 is greater than 5? No, 2 is not greater than 5. 2 is smaller than 5 and it should be present on the left side. Now we got 2 flag index. Okay, so let's remove this, swap it. Okay, so now let's see that 4, 1 and 2 are the smaller elements than the pivot element. Okay, and 6 and 7 are the greater element than the pivot element. Okay, so now our task is done. Okay, so we have shifted all the smaller element towards left and all the greater element towards right. Now our main task is to call the recursive function. What our recursive function will do is, we have made the pivot element to its correct position. Let's say if we sort the array will be look like 1, 2, 4, 5, 6 and then 7. Okay, so 0, 1, 2, 3, 4, 5. So you all can clearly see that if the array will be sorted, 5 is in its correct position, which is in index 3, and we have like put the 5 in its correct position, so we don't need to worry about 5. Okay, so one element we have moved at its correct position. Okay, so now 5 is in its correct position. Okay, done. Now what we have to do, we have to call two recursive function. Like I'll tell the recursion that, okay, recursion, just do one thing, sort the left part of the array and sort the right part of the array. Okay, so this will be recursive function 1 and this will be recursive function 2. So this will in the range, this will be in the range s2 pivot index -1, and this will be in the range pivot index +1 till end. Okay, now what the recursive function will do is, now our array will split it into 4 1 comma 2, and next array is 6 comma 7. Okay, so I'll be explaining one more step. Okay, so this is the complete step which we have to follow, and else recursion will handle all the things. Okay, so now again what I have done, follow the steps, start and end. Okay, so let's declare this start and end. Okay, done. Now next thing what we have to do, find the pivot element. Always pivot element will be the start. Okay, done. So pivot element is this. Okay, so pivot will be equal to 4. Now what we have to do, make 4 at its correct position. So now calculate. Okay, so before 4 some elements will be there, and after 4 some elements would be there. Okay, so what we'll be doing, we'll be iterating in the like whole array from S to E, and we'll be checking that what are the numbers that are less than 4. Okay, so we got 1 which is less than 4, 2 which is less than 4, so we got 2 elements. So we'll like swap the number 4 with the index 2. Okay, so after swapping it, our new array will be looking like 2 1 and then 4, because this is 0th index, 1 and 2. Okay, so now 0 1 and 2. Okay, so now 4 is at its correct position. Now what we have to do, we have to make sure that whatever number before 4 should be less than 4, and whatever numbers in right should be greater than 4. Okay, so we can see that. Okay, so again like we have followed this step, pivot element, move the pivot element to its correct position, and left of pivot element should be smaller and right of pivot element should be greater. Okay, so left of pivot should be smaller. Yes, it is smaller. Now there is no elements at its right. Now again recursive function will be called, and recursive function's range would be this one. So this is our pivot element, and it will call again, like the range would be s comma p minus 1. Okay, now again if recursive function will be called, so it will be 2 comma 1. Let's again find follow these steps. So start and end. Okay, our start will be this, end will be this. Now find the pivot element always be the first element. Okay, so p is equals to 2. Now what is the next step, move pivot to its correct position. So moving pivot to its correct position, let's count that what are the elements that is smaller than 2. Okay, so there is only one element that is smaller than 2, so we will swap the pivot element index with index 1. Okay, so this is 0, this is 1, so swap it. Okay, after swapping it, our array will look like 1 comma 2. Now 2 will be its at its correct position. Okay, so this is 0, this is 1. Okay, so 2 at its correct position. Now we have to make sure that left of 2 should be less and right of 2 should be greater. Okay, so yes, left of 2 is smaller because 1 is smaller. Okay, so we have found it, like we have sorted it. You all can see that we have sorted it. If now left part of 2 is smaller, now recursive function will goes like s comma p minus 1, and whenever we got to know that, this is our base case, that whenever we got to know that s and p minus 1 is only the single element, then we will be directly returning it. We don't need to perform any operation. Okay, so we have for 2 index we have found that 1 and 2 is the correct position. So let's like swap it. Okay, so from here we have called now, so it will be 1 and it will be 2. Okay, so 1 2 and 4. Okay, so now we have to change it 1 2 and then 4. You all can see that this part is sorted. Now similarly it will work for right index, like a right part of that 5. Okay, so this is how the algorithm for quicksort is working for one dimensional array. Okay, so before that, let's see the code for quicksort. Okay, so the code for quicksort is very simple. Okay, so this is our array. Okay, now we have to perform the quicksort. Okay, so let's see what we are doing in the quicksort. Okay, so what are the steps which we have to do? We have to initialize the what is the starting and what is the ending. Okay, when you got to know that start and end is start is greater than equal to e, it means that start and e is either pointing to the same index, or start minus index absolute value is 1, means there is only one element. So it is already sorted, so we don't need to perform anything, we will be directly returning it. Now what we have to do, next thing what we are doing is we have to find the partition. Okay, so what partition is doing, let's see here. So partition is only doing that, find the pivot index. Let's see the function what partition is doing. Okay, so what I have explained the same thing. Find the pivot index. Pivot index will always be the start. Okay, now we have to count what are the elements of the array which is less than equal to pivot index, and we'll be counting it, and we will be swap the pivot position with that count. S plus count means whatever elements we are starting with, whatever index we are starting with plus count. Okay, so we have swapped it. Now what we are doing after swapping it, okay, okay, so after swapping it or moving pivot index to its correct position, what we have to do, left of pivot should be small and right of pivot should be greater. Okay, we have initialized I in S and J in E, just like I have told, like initialize I from this and J till J on this. Okay, now what we are doing, while I is less than pivot position and J is greater than pivot position, it means that, okay, so I is less than pivot position and J is greater than pivot position, our pivot position is this. Okay, then we will slowly shift I towards this and J towards this. Okay, so what we are doing, we will be making a while loop while array of I is less than pivot index. It means that this is our pivot index and this is our I. We will be moving our I in right direction till we are getting the elements which is smaller than pivot index. It means that we have to make the elements, we have to make sure that the elements which is on the left of that pivot index should be smaller. Okay, so we'll be moving the I till the point till elements are smaller than pivot index. Okay, now next thing, array of J is greater than pivot index, then J minus minus. Okay, until and unless you are getting J which is like greater than pivot index. Okay, so this is good, we will be like moving towards left. Now when we got an element which is smaller than pivot index, so it should be here, but it is like on the right side. So we'll stop the J, we'll stop the I and we'll swap it. Okay, so finally what we are doing, we'll swap it and we'll be returning the pivot position. Now after returning the pivot position, okay, so what we are doing, let's see. Okay, so after returning the pivot position, what we are doing, we will be calling the recursive function. Okay, so let's remove this. Okay, so we will be calling the recursive function from the pivot index, means S comma pivot position minus 1 to pivot position 1 plus 1 to E. Okay, so let's see what we have done here. S comma pivot position, this is pivot position minus 1 and pivot position plus 1 to E. Okay, so I think till now it is clear that how quicksort is working in one dimensional array. Okay, so now let's shift to linked list. Okay, so let's take an example that this is the linked list and we have to sort it. Okay, so rest every step will be same, but one thing would be like in this also let me write all these steps. Okay, so these are the steps that we have to follow in order to apply the algorithm in the linked list. Okay, so these are the steps which is same as what we are following in the arrays, in case of arrays. Okay, so now what are the challenges that we are going to face while solving this applying this algorithm in the linked list is, in the array, what we have done is, like, let's say we have identified the pivot element. Okay, now if we have to make sure that whatever elements towards the left of that pivot element and whatever elements that is towards the right of this pivot element, it should be smaller and it should be greater. Okay, so what we have done in order to solve this, we have make one I pointer. Okay, we have make one j pointer, and what we are doing, like we have made run a while loop, and we'll be doing I plus plus till when, like when we get the smaller element. Okay, so it is safe, move I forward. Again we got the smaller element, move I forward. Okay, so it is still okay, but in j what we are doing, okay, so this is greater, move j backward. Okay, so now again we got j greater, again move backward. But in case of linked list, we cannot like move the pointer backward in backward direction. So now how we are going to solve this problem? So first what we have to do, identify the start and end. Okay, so the start is this index, like this one, and the end is this. Okay, done. Now what we have to do is, we have to find the pivot element. Okay, so this is our pivot element. So let's save it somewhere, like pivot is equals to 3. Okay, done. Now what we have to do is, this is our start. Let's remove this. We all know that this is the fresh linked list, so this is our start and this is our end. So now what we have to do is, we have to move the pivot element at its correct position. So how we are going to do this? Now listen it very carefully, how I am going to perform this two step at one go. Okay, so move the pivot element at its correct position, and make sure that the left of pivot is smaller and right of pivot is greater, while simultaneously I'll be performing both the steps. Okay, so let's see how I'm going to do this. Okay, so I'll be making one pre-variable like pointing towards head, and one current variable that is also pointing towards head. Okay, so now I'll be checking that, okay, so 3 is smaller than pivot. No, 3 is equal. Okay, so no need to do anything. Let's move current forward. Okay, so is 5 smaller than pivot? Okay, no, 5 is also not smaller than pivot, so let's move it. Okay, now is 2 smaller than pivot? Yes, 2 is smaller than pivot. Then what we have to do, because pivot is 3 and 2 is smaller than pivot, like current position is standing on 2. Now what we have to do is, we have skipped this part 5. Why we have skipped this part? Because this is greater than. Now previous next element will be swapping it with current element. Okay, so let me repeat this. Okay, so 2 is smaller than pivot, so let's just swap it. What is the way for swapping it? Okay, so what we are going to do is, we'll make one temp variable. Temp will save the current data, which is equals to 2 in the temp variable. Okay, saved. Now what we have to do, previous next. Okay, now temp is storing our current data. Done. Now what we have to do is, current data is equals to previous next data. Okay, it means that like we have to swap the value, this one, this 5 and this 2. So how we are going to do this? Okay, so let's make a temp variable. I have made a temp variable and initialize the current data with it. Okay, now I'll make the current data which is equal to the previous dot, or I can say arrow, next, and this one will be data. Okay, done. So what it will be? It will be 5. Automatically it will be 5, because previous next data is 5 and I'll be storing in the current data. Now what will be our previous next data? Previous next data which will be equal to our temp variable. So what is stored in our temp? So it will be cut and it will be stored as 2. So let's remove this and make the 2. Now remove this and let's make it 5. So now we have changed the previous next data. Okay, so now this value is also safe. Okay, so let's move the previous one step ahead. Now let's move current also one step ahead. Okay, so now 1 smaller than 3? Yes, 1 is smaller than 3. Then again what we have to do? Again follow the same step. Store the current value in the temp. Okay, current value is 1, so store it in the temp. Now current data, we have to swap this. Okay, we have to swap this value and swap this value. Okay, so now current data is equals to previous next data. Current data, which is this, is equals to previous next data, means 5 will be stored in this one. Okay, done. Now previous next data is equals to temp. Previous next data means this one is equals to temp, which is equals to 1. Okay, so we have smartly swapped the value. Okay, so now 1 is also safe because it is also less than pivot. Okay, so let's move previous. Let's move previous now, and also let's move current. Okay, now is 4 less than 3? No. So let's move current one step again ahead, and we have come to an end. Now if we have come to an end, now what we have to do? We have to make sure that whatever elements present on the left side and whatever elements present on the right side of pivot, this should be greater, this should be smaller. Now this is the pivot index. We have to move to its correct index. So what is the correct index for this? If we swap it, okay, so let's remove this. Previous is standing here, current is standing at the end of the linked list. Okay, so if we swap to the previous next index, then what will happen? 3 will come here and 5 will come here. Okay, so we have moved the pivot index here, but 5 should be in the right of 3 pivot index. Like 5 is greater, so it should be on the right. So we will not swap it with previous next. So now what we'll be doing, we'll swap it with previous, like pre element. Okay, so we'll swap the pivot element with the pre index. Okay, so let's move it to 1, let's move it to 3. Now you all can see very clearly that this left index and this right index, we have smartly handled that the left elements of pivot element is smaller and right element of pivot index is greater. Now again what we'll be doing? Again the recursive call, because we have followed this step and these two steps in one go. Now what we are doing? At last we have swapped the value. Okay, done. Now what we are doing? We'll call the recursive function. Now how recursive function is working? Okay, so initially this is our start, this is our pivot. Okay, done. And this is our end. So how this recursive function will be going? Recursive function will be going like s till pivot minus 1. Okay, or we can say that s till pivot, and recursive function will goes like pivot dot next means handle from this till end. Okay, so you all can see that. So now this will calculate our answer and give the sorted linked list. Okay, by swapping all the values. Okay, because you all can see that this is fixed, 3 is fixed. Now 1 or 2 linked list will be there. Okay, so 1 or 2 again it will find the pivot index. Now we'll make the current here, then pre here, and we initialize the pivot index as 1, and it will calculate, like recursive function will be like able to sort the linked list. Okay, so now let's move to the code. Okay, so how code is working? Okay, so let's start from the starting. So this is our main function, quick sort, we have to implement. So what we have to do first is we have to identify the start and end. Okay, so we are only provided with the head of the linked list. So what I have done here is I have calculated the tail of the linked list by find tail. I'm doing nothing in find tail. What I'm doing, I have just iterated the linked list, and while I get into the last element of the linked list, I marked it as tail and finally returned it, return the tail. Okay, so head is already provided, tail I have calculated, I passed it in the quick sort OG. Okay, so it is head and tail. Okay, so now what is in the OG? In the OG I got the head, I got the tail. Now what I am doing is, if head double equal to null, it means that there is no element to sort, directly return. If head double equal to tail, it means that there is only single element which is already sorted, then directly return, which is our base case. Now what I'm doing, I am calculating the pivot index. So here pivot element, which is the start element. So pivot from the partition. Now let's see the partition function. Okay, pivot partition function is very small. Like I have the head and tail. I have passed in the partition function head and tail. Let's see the magic. Like I have made the pivot element as the starting, which is the head here. Okay, so pivot element as like it was 3 initially, because the array is like what is the array, 3 4 2 1, like somewhat like that. So pivot element was the starting, which I have taken as 3. Now I have made a pre and current, which is also starting from the head. I have, if you remember, I have made pre also here and current also here, and start iterating. Okay, while current not equal to tail next, like, okay, so why I have done tail next, why I have not done like head next? Okay, so the reason is very clear. Like from this like from the fresh linked list, we know that it is head. Okay, so from the fresh linked list, we know that this is the head, this is the head, and this is the tail. But if we move this, so our head is this, our tail is this, so it's better to move till tail. Okay, so now current is, while current is not equal to tail next, which is equals to null. Okay, so what we are doing, if current data is less than pivot data, so what I have done here is, if anytime current data is less than pivot index data, so what I am doing, temp is equals to current data, the same step, temp is equals to current data is equals to previous next data, current data is equals to previous next data, and previous next data is equals to temp, previous next data is equals to temp. Just watch the video one more time while I was explaining this, how I have like come up with this, so you will be very clear. Now what I'm doing, I'll move the previous to previous dot next. Why I'm doing here, because I have make this element as safe. Okay, now after moving this, every time I'm doing current is equals to current ka next. Okay, so after I iterate from this while loop, what I'm doing, okay, so I have shifted all the like smaller elements towards left and greater elements towards right. Now it's time to swap the pivot elements to its correct position. So I swap, if you remember, I swap the pivot element with the pre element. Okay, so same I'm doing here. Like current d is equals to pivot data, I stored it. Now pivot data is equals to pre data, and pre data is equals to current d. Instead of doing this, I can also directly write it like swap the values. Okay, so let me directly write it. So I have reduced the code, like instead of doing all those stuffs, you all can directly like swap the values. Okay, so here what we are doing, pre next data with current data. Okay, we have swapped it. Now after running this while loop, what we are doing, we are swapping the pivot data with the pre data. Okay, so that pivot data with the pre data. Okay, once we have swapped it, then we are returning the pre position, means we got the pivot element as here, so that we can pass it in the recursion that run it like here and here. Okay, so now after getting the pivot index, what we are doing, we are running a quicksort OG again. This is the recursive function, and till where we are running, from head till pivot, and pivot next till tail. It means that from head till here, and pivot index dot next till tail. Okay, so this is how we are like calculating it. So let's run the code. Okay, so let's compile it. Okay, so it's passing, so let's submit it. So I hope the concept of like quicksort, okay, so it has passed all the test cases. So I hope the concept of that like algorithm for quicksort is clear. Within 3 to 4 steps, okay, maximum 4 steps, we have understood how we can apply the quicksort algorithm in case of arrays and in case of linked list. Okay, so I hope the code is clear and I was able to like deliver the approach how to solve this problem. So thank you for watching and having patience. So thank you.